Hello, so we're going to do some limits as x approaches infinity and negative infinity with some equations and some functions. So let's look at this first question. So the limit as x approaches infinity of 4x over 3x squared plus 1. So whenever we have a function where the degree of the denominator is greater than the degree of the numerator, so the degree of the denominator is the highest exponent that we have, so the degree of the denominator would be 2, and the numerator's degree would be 1, because our highest exponent is 1. So whenever we have a function whose degree of the denominator is higher than the degree of the numerator, then the limit is going to equal 0. So why is this? Because this 3x squared term is going to grow much faster than the 4x or the plus 1. So the plus 1 won't grow, but the 4x is going to not grow as fast as 3x squared. So because 3x squared is going to be growing faster, that means that this 3x squared term is going to be much bigger than the 4x term. So what that means is if we have a denominator which is much bigger than the numerator, then, so for example, if we have a denominator like that is much bigger than the numerator, so like 100,000, and our numerator is say like 1. So this is going to be very close to 0. It's going to be like 0.01, right? So this is going to be very close to 0. So as we increase our, as we get even larger denominators, it's going to get even closer to 0. So that's why whenever we have a denominator with a degree higher than the numerator, then this limit is going to equal 0. So this answer is going to be 0. Alright, so for our next one, so the same thing, we can use the same thing for this problem right here. So we first find the degrees. So the degree of the numerator, the highest exponent, is going to be 3, and the degree of the denominator, the highest exponent, is going to be 2. So because x is approaching infinity, as we grow, so as we get closer and closer to infinity, this 3x cubed term is going to be much larger than all of these terms combined, because we have an x cubed, because x cubed grows much faster than x squared and x and just that 7. So even though we are adding all these terms together, this 3x cubed term is going to grow much faster than the denominator's terms. So what happens when we have, so that means that we're going to have, the numerator is going to be much larger than the denominator. So whenever we have a numerator much larger than the denominator, so like say this numerator was like 100,000 and the denominator was 1, this is just going to be 100,000, another very large number. So as we get closer and closer to infinity, this limit is going to get, this numerator is going to get closer and closer to infinity. That means that this entire limit is going to get closer to infinity, and so our answer is going to be infinity. Okay, so we have one last one. So this one asks, the limit as x approaches infinity of 3x squared plus 4x over 4x squared. So first let's find the degree of the numerator and the denominator. So the degree of the numerator is going to be 2. our highest exponent, and the degree of the denominator is going to be 2 as well. So when the degrees of the numerator and denominator are equal, what we do is we divide the coefficients of these highest degrees. So this x squared is our highest term, degree term, and this x squared down here. So we would just divide these coefficients. So we would just divide the coefficients to 3/4. So again, we can use this thinking where this 4x squared term and this 3x squared term are going to get much larger than this 4x term right here as x approaches infinity. That's why we can we don't have to worry about this 4x term, because this 3x squared term and 4x squared term are going to get very large very quickly, and they're going to just dwarf the 4x term. So this is just saying that because it's dwarfing the 4x term, it's the same thing as saying the limit as x approaches infinity of 3x squared over 4x squared. And we can cancel these x squared terms out, and it's going to be the limit as x approaches infinity of 3/4. So the limit of any constant function, so this is a constant, right? So since this is a constant, it doesn't matter what our limit is. So this is just going to equal 3/4. So the limit of anything of a constant is just going to be that constant. So we're going to have, so our answer is going to be 3/4. So we could have done it this way, or we could have just divided the highest degree coefficients. Okay, thank you.